Myself, C. Sivakumar, working as Assistant Professor in Mathematics, Dr. N.G.P. Arts and Science College, Coimbatore. In this video, we are going to see about what is a graph, then finite and infinite graphs, incident and degree, then isolated vertex, pendant vertex, and null graph. Finally, we are going to see subgraphs. First, what is graph? A graph or a simple graph is denoted as capital G of two pair of symbols V and E. Here V is set of vertices like V1, V2, V3, and E is set of edges is denoted by E1, E2, E3. Here each edge EK is identified with an unordered pair Vi, Vj of vertices. The vertices Vi, Vj associated with edge Ek are called the end of Ek. The most common representation of a graph is by means a diagram in which the vertices are represented as points and edges are line joining segment its end vertices. Next, diagrammatical representation of a graph. In this page, there are 5 vertices named as V1, V2, V3, V4, V5 and 7 edges E1, E2, E3, E4, E5 and E7. Here the edge connect with 2 vertices. For example, here V1 is a vertices, V2 is another vertices. Join this line named as E3 is called edge. This edge connect V1 and V3 as a vertices. Then what is a graph? A special type. The definition permits an edge to be associated with a vertex pair Vi, Vi. Such an edge have the same vertex as both its end vertices. Is called self loop or simply a loop. In the above diagram, there are one loop. Here one is a self loop. Okay. Next, parallel edges. The definition allows more than one edge associated with a given pair of vertices. Such edges are referred to parallel edges. Then the above figure, edges E4 and E5 is a parallel edges. Next, simple graph. A graph that has neither self loop nor parallel edges is called a simple graph. Next, here there are 2 graphs A and B. Both are 4 edges and 4 vertices and 5 edges named as 1, 2, 3, 4 are vertices. Like B is also have 4 vertices 1, 2, 3, 4, but the diagrammatical representation is different, but both are the same graph. Next, intersect at a point. In this diagram, the edge E and F intersect at this point, but this point not a vertex. This type of point is intersect at a point, but this is not a vertex. Next, finite and infinite graph. We already the example of finite graph in previous video like that graph or finite graph. Here infinite graph is shown in this diagram. A graph with a finite number of vertices as well as finite number of edges is called a finite graph. In the above example, there are 5 vertices and 7 edges. So the edges and the vertices are countable, that means finite. So we call the finite graph. Otherwise, it is an infinite graph. In this diagram, both are infinite graph because there are a lot of vertices and edges there in the diagram. Next, incident and degree. First, what is mean incident? When a vertex bi is an n vertices of some edge ej, vi, ej are said to be incident with each other. For example, in this diagram, edge E2, in this diagram, edge E2 and E6 and E7 are incident with V4. That means 3 edges connect with the single vertex V4, so that we call incident vertex V4. Okay, next, adjacent. Adjacent means there are 2 edges starting from one point and from the another one point. That type of edges are in adjacent. Here formally we define 2 non-parallel edges are said to be adjoint if they are incident on a common vertex. In this diagram, edge E2 and E7, edge E2 and E7 are adjacent. Okay, next, degree. What do you mean degree? The number of edges incident on a vertex vi with self loop counted twice is called the degree. In symbolically we denote as d of vi, means degree of that particular vertex. For example, in the same diagram there are 5 vertices and the degree of V1 means there are 3 edges E3, E4, E5 connect with the single vertex V1. So the number of edges connect with that particular vertices is counted, and that is called a degree of the vertex. That from the diagram, degree of V1 is number of edges connected to V1 is E3, E4 and E5. So 3. Then degree of V3. Degree of V3, there are 3 edges E4, E5 and E6 connect with V3. So degree of V3 is 3. Likewise, degree of V4 is 3. Degree of V2 is 4 and degree of V5 is 1. Okay. Next, note that sum of the degree of total vertices in that given graph is twice as a number of edges in the given graph. For example, here in the same diagram there are 5 vertices and have some degrees. So we add these degrees vertices wise. So degree of V1 is 3, degree of V2 is 4, degree of V3 is 3, degree of V4 is 3, degree of V5 is 1, totally 17. This is equal to 2 into number of edges. Here there are 7 edges like V1, V2, V3, V4, V5, V6 and V7. 7. So 2 into 7 or 14 is equal to number of edges, twice of number of edges. Okay. Next, isolated vertex, pendant vertex, and null graph. Okay. First, isolated vertex. A vertex having no incident edge is called isolated vertex. In other words, isolated vertex are vertices with 0 degree. A vertex having 0 degree means is called isolated vertex. For example, in this diagram, vertex V4 and V7 not having degree, not having connecting edges. So V4 and V7 are called isolated vertices. Okay. Next, pendant vertex. A vertex of a degree is called a pendant vertex or an end vertex. For example, in this diagram, vertex B3 connected with only one edges with V5. So degree of V3 is 1. This is called pendant vertex. Okay. Next, null graph. Null graph. In the definition of graph, it is possible for edge set E to be empty. Such a graph without any edges is called null graph. For example, here there are lot of vertices V1, V2, V3, V4, V5 and V6. All vertices not connected with an edge. So this is a null graph. Next, subgraph. A subgraph. A graph G is said to be subgraph of a graph G if all the vertices and all the edges small g are in capital G, and such edge of G is the same n vertices in small g as in capital G. For example, here diagram A and diagram B both are graphs, but the diagram B is a subset or a one part of the diagram A. Here vertex V1, 1, 2, 3, 4 is cut and pasted separately and put name as B. So diagram B is a one part of diagram A. This type of graph is subgraph. Okay. Next, observation of subgraph. Every graph is its own subgraph. That was point. The second point, a subgraph of a subgraph of G is a subgraph of G. The third point, a single vertex in a graph capital G is a subgraph of capital G. Then the fourth point, a single edge in capital G together with its end vertices is also a subgraph of G. Okay. Next, a summary of this lecture. In this lecture, we learn about what is a graph and its types. Next, a representation of finite and infinite graphs. Then, how to calculate incident and degree of a given graph. Finally, identify isolated vertex, pendant vertex, and null vertex. Thank you.